Okay, so welcome to our lesson, guys, on 7C. This follows on directly from the sine function. So we were looking at the sine wave. And you might remember when we first started with the sine wave, we used our calculator to determine these values, and then we did that big graph. Okay, we did one big graph and we generated the sine wave. We could do the same for the cosine wave, but I think in a moment I might just bring up on the screen and show you where it's coming from. But the cosine wave is almost the same as the sine wave, except that it starts with a peak here. So you might remember the sine wave starts here and goes like that. The cosine wave is the same, except it starts with a peak. All right, so they're the same function, except one is a horizontal translation of the other. If we pick this function up and move it that way a bit, you can see we'll generate this same wave. Cosine, so if this is the graph of y equals cos of x, it has the same amplitude and it has the same period. And we have A, B, C, and D have the same effects that they do on the sine function. Okay, so that's our basic cosine function. We're asked to graph this function. All right, so we have 2 cos of x on 2 plus 3. So I'm going to talk about how we could think about this. The first thing is whenever we have x divided by 2, we should always think of that as half times x. Alright, we should always think of that as a fraction times the value of x. And that's going to help us as we're moving into calculus and so forth in semester 2 and next year as well. Okay, then we'll identify the values of A, B, C, and D. So A is the amplitude, that's the number that hangs out the front. That's the distance from the principal axis to a peak or a trough. In this case, A is 2. The value of B is the coefficient of x. That means the number in front of x. The coefficient of x is positive half. Now, what does the B value mean? It means there is half of a wavelength in 2 pi. All right, half of a wavelength in 2 pi. And then the D value outside the brackets is the vertical translation. It's been moved up 3 units. It's our principal axis. So if we're going to sketch this, here's the x-axis, here's the y-axis. We have a principal axis of 3. D is 3. That's going to be the first place that we start. So the function propagates itself about that line at 3. And it has an amplitude of 2, which means the highest it's going to go is up to 5, and the lowest it's going to go 3 down 2 units would be 1. Okay? So we're getting those values there. The other thing we'll start to think about is its wavelength. We have half of a wavelength in 2 pi. So if here's half of a wavelength, then a full wavelength is going to exist in 4 pi. Okay? Now, for a cosine wave, we will always start at a peak. So we're going to start at a peak here at 5. And we have half of a wavelength in 2 pi. And then a whole wavelength in 4 pi. So that's where we're going to come back up, and right here will be at the bottom. So it's going to look like this. Okay. Now that's a whole wavelength because you can see we have a whole peak here. We have, a whole trough here. We have half a peak there and half a peak there. So 1 peak, 1 trough makes 1 whole wavelength. That's what the graph, I've come way too low. That's what the graph is going to look like. The lowest point is 1. There we go. Okay. So amplitude of 2, 2 up, 2 down, principal axis of 3, and we have half of a wavelength in 2 pi. Now, if we were going to sketch this on our calculator, all right, basically we're going to need to, we can just type that in, that's fine, but we're going to need to adjust the V window a bit. We're interested in graphing from 0 to 4 pi on the x-axis, and probably from 0 to 5 or 6 on the y-axis. Okay, so that can come straight from the graph. Okay, next let's look at the opposite case where we have a graph and we need to determine the equation from this graph. So when we were doing this yesterday, I said we won't ask you about horizontal translations, we'll just ask you about A, B, and D. So D is the principal axis, right? That's the line about which the function propagates itself. That's going to be 2. Our value of D is 2. The amplitude is the distance from a principal axis to a peak or to a trough. So our amplitude is 1. And the value of b is how many wavelengths are there in 2 pi? Well, what we can see is that we have 2 wavelengths in pi, which means if we were going to go all the way out to 2 pi, we would have 4 wavelengths. So our value of b is 4. So the equation of this function then is y equals 1 cos of 4x plus 2. And we don't technically need that 1 at the front there, but I'm just putting it there to show you that's where the amplitude goes. So if we graph y equals cos of 4x plus 2. Okay, very good. So that's the cosine function. A bit like with the sine rule, there'll be a number of questions that get you to graph it. There'll be a number of questions that give you a graph and get you to find the equation. So both can be expected in the test. Make sure you're comfortable with both procedures. Any questions from up here? So that's the first part of our lesson. After recess, we will go over 7D as well. All right, so let's leap straight into it. Yeah, good luck with it. Sing out if you've got questions.